Hey guys, how's it going out there in the interwebs? So today what I want to talk about is two different architecture patterns or architecture styles, I guess, that are commonly used when people build, like web applications or SaaS applications or things like that that are typically hosted in the cloud. Before I do, take a quick sip of tea here. David's Tea, by the way, really, really good company, actually, if any of you guys are into tea. Canadian company, I think, as well. Anyway, monoliths and microservices. So what are the differences? What do each of those words mean? So I'll start with monoliths, because that's what people are typically most familiar with. So a monolithic application is typically the first type of application that people learn how to build. The best way to describe it is everything is kind of all together as one, and that's why it's called a monolith. You kind of have one code base that is the entire application. So if you're developing a web application, for example, it could be like a PHP web server, or if you're using Node, it could be something like Express or some other type of web server, and it's all just essentially just one application. And that application typically has a database that stores data as well, and it's typically just one database, usually a SQL database. Very often it's like MySQL or Postgres or SQL Server, something like that. So you have the application which talks to the database. And that's kind of how most people structure their applications. And it seems simple enough. I mean, it's very easy to deploy this type of thing, very easy to scale it. It's very easy to, build it initially just to get it off the ground. But more often than not, people have a tendency to run into a lot of issues when they're using monoliths as the size of the code base and the size of, the development team increases. So first off, let's talk about some of the advantages of a monolith. For starters, it's very easy to develop and test. Testing monoliths are very easy because everything is together, and it's very easy to write unit tests because all the unit tests are essentially the same. Everything is very, very, very consistent. So that's one pro of a monolith. The other pro is it's common tooling. Because everything is written in the same programming language, using the same frameworks, it's very obvious how to write code against it. Everything is kind of set in stone and very rigid. That can be a benefit. I'm going to try to convince you later that it can also be a con as well, but many people actually see that as a benefit. The other advantage is it's less infrastructure to manage. If you just have, say, one web server or one kind of web server, that's very easy to manage and scale. If you have one database, again, that's very easy to manage and scale on its own. That's it. Nothing else. Very easy to manage from an infrastructure perspective. And the last advantage is it's very quick to set up a monolith. When you're starting a new project, setting up a monolith is very easy. It's very easy to spin up a PHP web server. It's very easy to spin up, a Node.js server. So getting these things off the ground is incredibly simple. But there's many disadvantages to monoliths as well that I kind of want to talk about too. So the obvious disadvantage is that it's very hard to maintain a monolith as it grows in size. So think about if you're running, a software company that has, 50 people or 100 people or 500 people, and you have many, many development teams all working on this monolith. One problem that you could run into is it becomes very hard to change things because things are so tightly coupled together. Your database, for example, your SQL database, it's not uncommon for them to have, 200, 300, even 1,000 tables. And I've seen situations where changing the schema is incredibly difficult because you don't know what other teams are using what tables. And, in order to change something, you have to basically reach out to all areas of the company to figure out who's using what. And, just changing, adding a column could be like a 2-month-long project. So it becomes very difficult to maintain. It's also very hard to address technical debt. So for example, if everything is in the same programming language, you have this massive code base all in the same programming language using the same frameworks, you have a massive database. It can be very hard to upgrade to new technologies. Releases can also be very difficult. So, if you're a large tech company and you're doing releases, say weekly or bi-weekly or maybe even monthly, There's a lot of things packaged into each release because there's so many different teams working on that monolith that every release is going to have a huge amount of the code base touched. And when something goes wrong in a release, number one, it's going to be very difficult to track down what went wrong. And sometimes if you need to roll back a release because of problems, you have to roll back everything. So that can be incredibly frustrating as well. So one of the ways that people typically solve these problems nowadays is using something called a microservice architecture. Microservice architecture is basically where you can kind of think of like every object that you store or every database table in SQL like its own service. So suppose for example, we're running an e-commerce site. We might have a customer table, and we might have an orders table, and we might have a product table. All those in a microservices architecture would be their own services that have their own database. So you would have a customer service, an order service, and a product service, all which have their own distinct databases. And information would be pulled from those services through a REST API or a GraphQL API or something similar. And the only thing that would touch that service's database is the service itself. Now that obviously has a lot of huge advantages. Because there's nothing else touching that service's database, it's very easy to change the database. Because if you're managing now a microservice that has its own database, you know that nobody else is using that database, just the people running that microservice. Furthermore, you can make schema changes in the database very easy. You don't need to concern yourself and worry about, oh my God, is there anyone else using this particular table? You know there's not because it's only your microservice that is connected to that database. Also, microservices are deployed and scaled independently. So if you're a team that's managing a microservice, you can release that microservice, a new version of it, without worrying about any other microservice. And typically the way microservice architectures are structured in large companies is that you have teams that manage single microservices or groups of microservices. So they need to know only the code bases of those microservices. They don't need to care about what other technologies that other teams are using. But if they need data from other microservices, all they need to do is call the REST interface of that microservice. So for example, going back to our e-commerce example, if I'm on a team that's working on, say, the order microservice, and I need to pull customer data from the customer service when someone tries to order something to make sure, say, they have enough credit, the only thing I need to know about the customer microservice is its REST interface. When you think about it, when you use APIs from a lot of big companies that provide APIs like Facebook, if you use the Facebook API or the Twitter API, you don't need to know about what database technology Twitter is using. It doesn't matter. You don't need to know about what programming language they're using or how they've implemented things under the hood. All you need to know is how to call their API. That's it. And when you have a microservice architecture in a company, that's all that you need to know as well. Typically, these API definitions are written in something like Swagger or OAS, for example, and companies maintain a large set of these, so you can bring up the Swagger file for any microservice that you're interested in, see its API definition, and from there you can just call it. So this allows your teams to be truly autonomous. Furthermore, you can choose the best technology for the job you're doing. So I know I mentioned an e-commerce website previously. What if instead you were managing, a social network, for example? Suppose you had something like Facebook or Twitter. We talked previously about SQL. Maybe you're using a SQL database or, a NoSQL database. Well, what if the type of data that you wanted to store was relationships between people? Say if two people are friends or not. Now that's inherently a graph type relation. It doesn't really make sense to store a graph in a SQL database. It's very hard to do that. And the queries that you have to write are not really designed for graphs. Really what you want to do is use a graph database, something like Neo4j. So in a microservices architecture, you can have a relationship service and choose Neo4j as your database. However, it probably doesn't make sense for everything to be stored in Neo4j. So if you have a user service, for example, maybe it makes sense to store that in NoSQL. So the advantage of a microservice architecture is that you can choose the best technology for whatever data that you're working with. And lastly, because things are so loosely coupled and people deploy and scale each service individually, releases are much easier. So a team might release its microservice multiple times a week, and every time it's released, it's only that one microservice. So if something was to go wrong, say in a production environment, you would just roll back that one microservice and that would be it. So because of this, releases are actually much more frequent. I mean, you can have literally hundreds of releases every month across all your microservices. And there's actually less chance of failure as well. Now, that's not to say that this architecture doesn't have its downfalls. There's lots of issues and challenges that you can run into. The obvious one is that there's much more infrastructure to manage. Now, instead of managing just one web server with one database, you could have tens or hundreds of these microservices. And, coming up with like good standards and good practices around deploying them, that can definitely have its challenges as well. Another obvious challenge with managing microservices is how do you combine data from multiple microservices? So think about a SQL database. Suppose that you want to get all products from a particular set of customers. So if you had that in a SQL database, you would do it using a join. You would say, select star from customer, join product or order on, order.customer ID equals customer.id. Or something like that. So it's obvious how to do that with a SQL database, but how do you do that with microservices when everything is an individual service and it's exposed with REST? Well, the way you solve it is using what's called a materialized view. A materialized view is basically a service that combines two or more other services. So if you have, say, a customer service and an order service, and you want to see which orders belong to a particular customer, you would have, a customer order service. And the way that service would work is it would listen for events from the other services and update its data accordingly. So you would have, some sort of message queue like Kafka set up in your microservice architecture that all your services can publish events to. And they can listen to other services' events and update their state accordingly. So if we have a customer orders service, it would listen to both the customer and the orders microservice. And anytime those services' data change, if they add a new customer or a new order, then it would update its internal state accordingly. And it would essentially have the same data or similar data as those other two microservices, but it would be joined. So basically you would have this, in a way, write a microservice specifically to handle that type of query. The other challenging thing with microservice architectures is how do you handle testing, particularly integration testing. In a monolith, you have a web server that talks to a SQL database. Common type of integration test you might have is testing, your queries, for example, or testing that your CRUD methods to make sure they do what they're supposed to do. Now, how do you test that in a microservice architecture? But the real question becomes, what if you have a microservice that pulls data from a bunch of other microservices? How do you integration test against that? How do you test the connections between microservices? And there's two main ways I've heard about doing this type of thing. The first way is using something called virtual services. And what a virtual service is basically is a mocked version of another service. So if you want to run an integration test against another microservice, rather than spinning up this massive amount of microservices, you would have mocked versions of these other microservices that basically return mock data, and you would run your integration tests against those. That's one way of doing it. The other way is to deploy your microservice into a staging cluster that contains every other microservice, the whole thing. Then run your integration tests in that cluster. And if they pass, then you can promote your microservice into a production cluster. This is probably the better way to test because you're actually using real services in a staging environment instead of mocked services. So as you can see, there are some obvious, challenges to running microservice architectures. They're not easy. There's a lot of work in terms of infrastructure setup. Testing can be a challenge. As I mentioned before, joins can be difficult. The point I want to try to get across with this video, though, is that the pros generally outweigh the cons. They can be difficult to manage. There's a lot of complexity and there's a lot of moving parts, but the real advantage you get from using microservices is agility. Your teams are not tied to other teams. You don't need to like go asking around to all these other teams in the company when you want to make a change. You can just make the change and that's it. You have your own technology, your own frameworks, your own databases, your own technology choices that you can manage yourself within your team. So the real advantage is that teams are much more autonomous. They can move quicker, they can release things quicker, and they don't need to care about what anyone else in the company is doing. So when to use each type of architecture? Now there are certain cases where it probably makes more sense to use a monolith. You know, if you have like a small project that you know is not going to get too out of hand, like, you know, a personal blog or something really simple, then it probably makes sense to use a monolith. But I would argue that for any large software project that you're going to run in the cloud, any type of web application, it more often than not makes sense to use a microservice architecture. It's going to be a little more work to get it set up initially. It's a little more infrastructure work. It's going to require some thought when it comes to testing and deploying, but the pros definitely outweigh the cons. You will have an architecture that's very adaptable, that's very easy to address technical debt. You can upgrade pieces of it individually, you can release pieces of it individually, and overall it would just be a way better experience for development teams. You'll thank yourself in the long run. All right, so that's the end of my video. I hope you've learned something. If you've liked this video, please like it and subscribe to the channel. And yeah, I'll see you guys in the next video.